Welcome to this deep dive. Today we're looking at a really fascinating corner of the tech world, specifically the photodiode market. And we'll also shed some light on the closely related IGBT module market.
Yeah, they definitely overlap in interesting ways.
We've got a recent report here. It's from Cognitive Market Research, published just last month, April 24th, 2025. That's our guide for today.
Right. And our goal really is to pull out the key insights for you from this report. We want to understand what's actually fueling the growth here.
And maybe what the roadblocks are.
Exactly. Identify potential challenges and just give you a clear picture of the trends and, the opportunities in these tech sectors.
Okay, let's jump right in then, starting with the photodiode market. The report points to, pretty steady growth.
It does. It's not just a small increase either. It seems like a consistent upward trend, and it's happening across quite a few different industries.
Like which one specifically?
Well, optical communication, that's fundamental, obviously.
Yeah.
Then you've got increasingly sophisticated medical devices, consumer electronics we all use.
Right.
And big ones like the automotive sector and industrial automation, which keeps expanding.
It's kind of amazing how widespread these little light sensors are becoming.
It really is.
The report flags their role in things like LiDAR, light detection and ranging. Super important for self-driving cars.
Crucial tech there.
And fiber-optic networks carrying our data, intricate biosensors for medical tests, even high-precision measurement systems in manufacturing.
And what's driving this isn't just using more of the existing tech, right?
No, exactly. It seems like advancements in the actual semiconductor materials, making them smaller.
Miniaturization, yeah.
And boosting their sensitivity to light, those are big factors too.
Absolutely. Plus, you've got that whole push for more energy-efficient tech and high-speed optical sensing solutions. There's a real market pull there.
So let's talk numbers. What was the market size, say, last year?
Okay, so according to the report, the photodiode market was valued at around USD 514.8 million in 2024.
514.8 million.
Yeah.
The projection, where's it headed, looks pretty significant.
It is. By 2032, they expect it to hit USD 952.9 million.
Wow, almost double.
Yeah, which worked out to a compound annual growth rate, a CAGR, of 8.0% over that forecast period. Pretty robust.
8% CAGR. Okay, so what's the main engine behind that kind of expansion?
Well, the report highlights two main things. The increasing demand for high-speed optical sensors we mentioned, and also substantial ongoing investments in photonics technology itself. That's the whole science of light, basically.
And you can see this playing out in specific areas.
Definitely. Think about faster photodetectors needed for 5G networks rolling out everywhere.
Right.
Or wearable health monitors. They often rely on light sensing for tracking metrics.
Yeah, my watch does that.
Exactly. And those advanced safety systems in cars we talked about. Yeah. LiDAR and other sensors.
It really brings it home when you see specific examples. The report mentioned Hamamatsu Photonics, right? They introduced an ultra-sensitive photodiode back in November 2023.
That's right, specifically for biomedical imaging. It shows that cutting-edge innovation happening right now.
Okay, so that sets the scene. What about the current trends really shaping this market today?
Well, a big one is just more integration into optical communication systems. Our need for bandwidth, for faster data speeds, it just keeps going up, doesn't it?
Relentlessly.
So these components become more and more essential. Another key trend is LiDAR deployment. It's not just R&D anymore, it's getting put into more vehicles.
Makes sense. And medical diagnostics.
Yep. Expanding use there too, enabling more precise, maybe less invasive procedures.
And it's not just about putting them in more places. The photodiodes themselves are changing.
Right. There's a definite shift towards smaller, miniaturized ones, high efficiency too, and importantly, lower noise for cleaner signals, more accurate readings.
And the report also mentions some tech leaps happening, like underlying technology shifts.
Yeah, this is interesting. Progress in silicon photonics is a big one. Basically shrinking entire optical circuits onto a silicon chip.
So smaller, cheaper.
Exactly. Opens up all sorts of applications. Then you have advancements in avalanche photodiodes, APDs.
IBDs.
Yeah, they have internal amplification, so they can detect really faint light signals. Think long-distance fiber optics or sensitive scientific gear.
Okay.
And also ongoing work in photomultiplier technologies. Again, super sensitive detectors for specific uses.
Got it. Now, looking at where this is happening, the regional breakdown for 2024, that tells the story, doesn't it?
It certainly does. Asia-Pacific comes out on top. Largest share, roughly 45%.
45%. And why is that?
The report points to massive demand from consumer electronics there, obviously huge manufacturing hubs, plus rapid telecom infrastructure expansion,
Okay.
and also significant government investment trying to boost their own semiconductor capabilities.
Okay, so Asia-Pacific leads. Who's next?
North America holds a pretty significant 28% share that's largely fueled by strong aerospace and defense sectors, plus ongoing innovation in medical imaging tech.
And Europe?
Europe accounts for about 20%. They benefit from a strong research focus in photonics and sensor tech, especially for industrial automation applications.
So it's global, but Asia-Pacific is really the powerhouse right now.
Yeah.
Let's talk about the companies involved. Who are the big players here?
Well, it's a highly competitive market, as you'd imagine, but a few key players hold pretty significant shares. In 2024, Hamamatsu Photonics was the leader.
We mentioned them before.
Yep. They had about 19.20% market share. ROHM Semiconductor was next with 12.30%, and Everlight Electronics held 6.40%.
Okay, so Hamamatsu, ROHM, Everlight. And they're not just sitting back, I assume. What's their focus?
No, definitely not. They're heavily invested in R&D, trying to improve the core stuff, sensitivity, speed, spectral response, the range of light they can detect effectively.
Makes sense.
And they're also doing strategic things, partnerships, acquisitions to get new tech, and really targeting those high-growth areas like LiDAR, biomedical imaging, and advanced optical comms.
So looking ahead just to 2025, what's the expectation? More the same trends.
Pretty much. The report suggests the emphasis will continue on miniaturization, making them smaller, better energy efficiency, and seeing them adopted in even more advanced sensing applications.
Now, the report also talked about why photodiodes are often preferred. They're not the only light sensor out there.
Right, good point. There are other options like phototransistors or those APDs we mentioned.
So what makes photodiodes the go-to so often?
The key advantages highlighted are their fast response time, how quickly they react to light changes, also low noise characteristics, which means more accurate measurements, and just overall excellent light sensitivity. These things make them pretty indispensable in critical areas. High-speed optical communication needs that speed and accuracy.
Right, for data integrity.
Exactly. Industrial automation needs precision. Healthcare imaging needs sensitivity for better diagnostics. And, well, tons of consumer electronics use them too.
And this preference is actually growing. You're gaining market share within optical sensors.
Yes, the numbers suggest that. In 2024, photodiodes already had about 50% of the optical sensor market. The projection is for that to nudge up to 52% by 2025.
So outpacing some of the alternatives.
Yeah, growing faster than traditional phototransistors and even those high-sensitivity APDs in terms of overall market share.
And what's fueling that increased preference? What specific demands?
It really comes back to those key sectors again. Automotive safety systems, think automatic emergency braking, they need super reliable light detection.
Can't fail there.
Nope. Medical diagnostics demanding ever more sensitive imaging, and that relentless drive for faster data transmission speeds all need rapid, accurate light detection.
Okay, that makes sense. Let's shift gears slightly and look at the broader technological picture.
Right, the bigger innovation landscape.
What's driving the underlying tech forward?
Well, the rapid evolution of optoelectronics generally is a huge driver. We're seeing constant progress in silicon-based photodiodes specifically. Things like enhanced sensitivity, wider dynamic range so they can measure both dim and bright light accurately, and improved spectral response, letting them see more colors or wavelengths effectively.
And it's not just the photodiode itself, is it? There's integration with other tech.
Exactly. That's a really interesting angle. Integrating them with AI and the Internet of Things, IoT.
What does that enable?
Well, in smart automation, systems can react intelligently to light conditions. In predictive analytics, you can use sensor data to forecast trends, optimize processes, really powerful stuff.
The report gave some recent examples of innovation from 2023.
It did. Let's see, Hamamatsu, again with that advanced near-infrared photodiode for LiDAR, very important for autonomous driving and industrial tasks.
Okay.
ROHM Semiconductor brought out energy-efficient, high-speed detectors targeting next-gen communication systems. And Everlight Electronics focused on compact, high-reliability ones aimed right at that growing wearable health monitoring market.
So real tangible progress recently. Let's quickly revisit the regional growth. We know Asia-Pacific leads, but can we drill down a bit more?
Sure. So Asia-Pacific is definitely the fastest growing region. had 40% of the global market in 2024, projected to hit 43% by 2025. That's a strong CAGR of 9%.
9% CAGR just in that region. Wow. And which countries are leading the charge there?
Primarily China, Japan, and South Korea, driven by, big R&D investments and their established semiconductor manufacturing base.
Right. And North America. Still important.
Oh, yeah. Remains a key market, holds that 28% share we mentioned, supported by leadership in optical comms tech and its innovative healthcare sector.
Okay, I think that gives us a really solid picture of the photodiode market. Now, the report also brings in the IGBT module market. First off, for anyone listening who isn't familiar, what exactly is an IGBT module?
Right. So an IGBT module, that stands for insulated gate bipolar transistor module, it's basically a power semiconductor device. Think of it as a heavy-duty electronic switch.
A switch? For what?
For controlling high levels of electrical power very efficiently, used in demanding applications where you need to switch a lot of current or voltage.
Okay, heavy-duty switch. Why is it relevant to our photodiode discussion then?
Well, it's relevant because both are advanced semiconductor technologies, and they're often driven by similar big trends like the push for energy efficiency and general technological advancement.
Oh, okay.
Plus, you often find sophisticated systems need both advanced sensing, like photodiodes provide, and efficient power control, which is where IGBTs come in. They work together in complex systems.
Got it. So what are the main things driving growth in this IGBT module market?
The report points to a few key drivers. Number one is just the increasing global demand for energy-efficient power electronics generally, everywhere.
Thanks.
Secondly, the big expansion of renewable energy. Solar power, wind power, they rely heavily on efficient power conversion, and that's prime territory for IGBTs.
Right, converting DC from panels to AC for the grid, things like that.
Exactly. And thirdly, the huge growth in electric vehicles, EVs, they use IGBT modules extensively in their powertrains, motor control.
And the numbers back this up, the importance of these drivers.
They really do. The renewable energy sector, for instance, accounted for about 35% of total IGBT module revenue in 2024. That's huge.
35% just from renewables.
Yeah. And the EV market saw shipments jump 15% in 2024, which directly pulls more IGBTs into production.
Wow.
Even industrial automation applications, a more traditional market, saw solid 10% growth in 2024, again showing that need for efficient power management.
So a lot of positive momentum.
Yeah.
But like any market, there must be challenges, right? Things holding it back.
Yes, absolutely. There are definitely hurdles. One big one is how sensitive IGBTs are to high operating temperatures.
They generate heat when switching all that power.
Exactly, a considerable amount. And this means you need sophisticated, often quite costly, cooling systems, heat sinks, fans, sometimes liquid cooling to keep them reliable.
And temperature isn't just about cooling costs, it affects lifespan too.
Massively. The report highlights that for every 10 degrees Celsius increase in the operating temperature inside the module, its expected lifespan can potentially be cut in half.
Cut in half, wow. That really underlines the need for good thermal management.
It really does. Another challenge is something called switching losses. Every time the IGBT switches on or off, a tiny bit of energy is lost as heat.
Okay.
In high-frequency applications where it's switching really fast, these tiny losses add up. Traditional designs might lose up to 2% of energy per cycle. That impacts overall efficiency.
2% doesn't sound like much, but adds up fast.
It does, especially in large-scale systems or over time. Then there's cost, especially with newer materials.
Like silicon carbide.
Exactly. Silicon carbide, or CS, offers better performance, better heat handling, faster switching, but it's still generally more expensive than traditional silicon. That limits its use in really cost-sensitive areas.
Okay. And the usual suspects, supply chain stuff.
Yep. Like many tech sectors, especially semiconductors, it's vulnerable to supply chain disruptions, geopolitical issues affecting manufacturing, and material availability. That's always a background risk.
So some real challenges to navigate. Looking ahead then, what's the future look like for IGBTs? What developments are expected?
Well, the industry is definitely pushing for better efficiency and performance. The report talks about a shift toward 6th generation, or Gen 6 IGBT modules.
Gen 6, what's better about them?
They promise improved energy efficiency, so lower running costs, and reduced switching losses, tackling that issue we just discussed, plus better thermal performance.
And there was an example of this Gen 6 tech.
Yes, ROHM Semiconductor. They launched Gen 6 650-volt IGBTs back in January 2024, aimed specifically at solar energy applications.
Solar, okay.
They boast lower power losses, higher efficiency, using something Magnachip calls field stop trench, or FST technology. Basically, it's a clever internal design that helps them switch more cleanly, wasting less energy, crucial for solar inverters.
So real engineering improvements happening. What about those alternative materials like silicon carbide or gallium nitride?
There's definitely growing interest, significant interest, in these wide bandgap materials, 6C and GaN.
Why the interest?
Fundamentally, they offer better thermal conductivity, they handle heat better, and can switch much, much faster than silicon.
But they're more expensive, you said.
They are, currently. But their performance advantages are so compelling for demanding applications, EVs, aerospace, high-end industrial stuff, that adoption is growing, where efficiency and thermal management are absolutely critical. The cost is coming down, too, slowly.
Okay, great. We've covered a lot of ground today, deep dives into both photodiodes and IGBT modules. Let's try and connect the dots as we wrap up.
Yeah, I think the clearest takeaway is that both these markets are seeing really significant growth. And interestingly, they're riding parallel waves.
Driven by similar underlying trends.
Exactly. Technological advancement is key for both. That global push for energy efficiency benefits both. And we see them both being adopted more and more in those same crucial sectors: automotive, renewables, industrial automation.
And it really feels like innovation in the basic materials and the device design is absolutely essential for both to keep progressing
Right.
and overcome their specific challenges.
Couldn't agree more. Tackling things like sensitivity and noise in photodiodes, or heat and switching losses in IGBTs, it all comes down to breakthroughs in material science and clever engineering.
And the competitive side seems dynamic too. Companies constantly pushing performance, looking for partnerships.
Definitely, no one's standing still. And that strong growth in Asia-Pacific really highlights the region's increasing weight in the whole semiconductor ecosystem, both manufacturing and adoption.
Right, it underscores that shift.
Yeah.
Okay, so just to recap the headline figures. The photodiode market projected to nearly double by 2032, hitting almost $1 billion. That's an 8% annual growth rate.
Driven by that relentless demand for high-speed optical sensors, everywhere from 5G infrastructure to medical wearables to car safety systems.
And this whole photodiode story is really tied into broader semiconductor advances and that big push for energy efficiency.
Which directly connects to the IGBT module market, playing that vital role in power control, especially in massive growth areas like renewable energy and electric vehicles. They're really two sides of the modern electronics coin in many ways.
Okay, so here's a final thought for you, our listener, to chew on. Given these incredible ongoing advances in how we detect light and manage power more efficiently, what other, perhaps surprising applications might emerge for these technologies soon?
Yeah, where else could better light sensing or power control make a huge difference?
And how might these seemingly small components continue to shape the world around us in ways we maybe haven't even thought of yet?
Interesting question to ponder.
Definitely. Thanks for taking this deep dive with us today.